Triangle ABC is isosceles, and the measure of angle A is 74 degrees. What must be the measure of another angle of this triangle? So notice it says what must be, not what could be, because there could be certain angles depending on how the triangle works out, but what must be that other angle. So let's go ahead and draw this. We know it's isosceles, but they don't tell us what parts of ABC are isosceles. So right away we might be running into some issues, but let's see. We've got an isosceles triangle. What could we have? Well, let's imagine that this is isosceles like that. Those two sides are isosceles. Let's imagine that one of those angles is 74 degrees. Okay, so we know that in this scenario, this must be 74 degrees because the base angles are equal. And if we do the math on it, this adds up to 148, which means this must be 32 degrees. Okay, looks fine. And by the way, this is angle A, angle B, angle C. Okay, well, how about this case? How about, let's do the same triangle, A, B, C. Instead, let's make this guy 74 degrees to start. Again, this would have to be 74 degrees, and this would have to be 32 degrees. So right off the bat, it seems like, the answer might be 32, because in both cases, the answer here is 32. But wait a minute. What about the situation where, again, we have ABC, but this guy is 74 degrees? Now, hold on a minute. Now, these two must be equal, right? All three of these must add up to 180, so we'll call this x and x. So we know that x plus 74 equals 180. 2x equals 106. X is 53. So we know that in this case, it could be 53 and 53. So in these three triangles, these are the only three choices we've got. Are there any situations where, or are there any angles that are always equal across all these triangles? Well, in case 1 and 2, the base angles are both 74, but in case 3, the base angles are 53. So the base angles do not have to be 74. And the angle at the top is 32 here, and it's 32 here, but it's 74 here. So notice in all cases, there's not one angle that must always be a certain degree measure. And it comes down to the fact that when we have this isosceles triangle, we just don't know where that 74 goes, what is isosceles, what is equal in that particular triangle, so we can't figure out anything. We've got two choices, right? We can either be this triangle or it can be this triangle. So looking at the choices, we know it can't be any of the numerical ones because none of those are guaranteed. So it's going to have to be E. It cannot be determined from the information given. We need more information in order to answer the question. And this is kind of a rare answer, to be honest. I haven't seen this be right on many SAT questions at all. Most of the time when you see this as a choice, it's a trap answer because what they want you to do is look at the problem, say, oh, I don't know how to do it, therefore no one must know how to do it, therefore the answer is E. So it's more likely to be a trap choice in those cases than to be correct. But here's an example of where it is. But notice it's correct because we can reason it out. There's a reason why we can't determine it, and it's because there's that ambiguity as to which triangle we have in this case. So the answer to this one is E.